In today's conversation, I get to talk to Avision Ho, Senior Data Scientist at the Department of Education. Avision has experience in developing parallel computing Bayesian machine learning applications deployed through R-Shiny. Outside of data science, Avision is passionate about cooking and baking, so after checking out his GitHub account, you can also check out some of his more culinary creations on Instagram. I was introduced to Avision through our common friend Martin Chan. Avision will be presenting at an R conference in London this September on why a Nobel Prize winning algorithm is not always optimal for business. So if you are around in September, that is definitely worth checking out. In this conversation, we talk about the transferable skills Avision took from his background in economics, the value of curiosity, and communicating data science with non-technical stakeholders. Avision also talks about how he feels learning Python opens you up to an increasing number of job opportunities, as it's a more widely used programming language with more use cases. Python is the go-to language for deep learning, cloud computing, and admin scripts. This is increasing consideration for data professionals when deciding what tools to learn. Python is especially popular amongst software engineers, machine learning engineers, and an increasing number of data scientists. Whereas R remains popular among data analysts, business analysts, consultants, researchers, statisticians, and a large community of data scientists. If you want to find out more about why R and Python are good for different tasks, you can check out previous videos on R versus Python. This space is developing rapidly, and I'm keen to have more conversations with friends and data professionals who work with R, Python, and other tools to explore what things are really worth learning. In the meantime, please enjoy this conversation with my new friend, Avision Ho. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. So I am here today with Avision Ho, and Avision was introduced to me by Martin. And could you tell us a little bit more about what you do?
Yes, so I work as a data scientist within the Department of Education, and what sort of I do as part of that is we would build models to predict risk, and these models will help inform our colleagues who are on the ground, so people who are more on the business side of things, to take action with the people that we work with should we identify that should we identify them as be risky.
Yeah.
Because the goal of what we do is to prevent these clients from failing.
Yeah, okay, that's great. And how did you get into data science originally?
Good question. So my academic background is in mathematics and economics.
Okay.
And I studied it in London. It's quite amusing because throughout my course, it actually started off with maths with economics. But after my first year of university, I realized I much more enjoy economics.
Yeah.
So I switched to do more economics in my course. And this was with the design that at the end, when I graduate, I would like to become an economist.
Okay.
This was also during a time when we had we were after the financial crisis, and we were reflecting upon sort of as a world really, the sort of failed prediction of economists as well. So it probably was a good time for me to become an economist. But at that time, I thought it's a very interesting field, and I was very captured by the models and the way you can explain phenomena that you see in the world. So how the financial system works, how political parties work as well, using these economic models, and to distill it down into a sort of equation. I found that quite poetic.
Okay.
So I graduated and I was looking for economist jobs, and in particular I was aiming for working for the Bank of England, because that was my interest, working for the macroeconomy and helping to influence policy in that sphere. But I didn't get it, so instead I applied to a body that worked with the Department of Education, and it so happened to be a data science role, and they saw enough in me to think that I could do a good job, and that's how I got into data science.
All right. No, that's great.
And what do you think were some of the core skills that they were probably looking for when they were looking for a data scientist?
Yeah. So the core skills they were looking for is, and I guess this applies to anywhere really, is a just natural curiosity and a desire to learn, as well as the confidence and perhaps the not having the not be caged by what you don't know, but rather seeking to learn new things and to learn how to do things. So it's being proactive and taking the opportunity to, yes, you don't know how to do this, but you know how to look for it.
Yeah,
in
no, I
the
think
great world of
that's
the internet.
really important, isn't it?
Absolutely,
Yeah.
yes.
And how do you think that you kind of managed to demonstrate that?
I think, so I think my sort of training as an economist
Yeah.
enabled me to gain this natural curiosity in the world and how systems in particular work. And I guess that sort of was shown in my answers when they were interviewing me and when I was working with other people in the assessment center where there were two parts there. There's an interview, there's a test, well, three parts: interview, test, and group exercise.
Yeah.
And I guess each segment that was there to help you demonstrate that you could work as a data scientist. Group exercise to show that you could collaborate with other people, because that's quite important in a data science team.
Yes.
Interview to show your own personal curiosity in how things work, and the test to show that you have the technical aptitude to understand some of the theory that underpins the sort of techniques you use in data science.
Okay. And so when you did your studies in economics and mathematics, what kind of technical skills were you learning? Did you learn any programming or anything like that?
So there was a particular course that I did as part of my degree called econometrics.
Okay.
And econometrics is actually applied statistics for economics.
Right.
So within that module, I would study things like regression models, which turns out is a very cool part of data science indeed. It was actually one of my favorite modules, so having the ability to enjoy a course that required you to learn both the theory and the practical application of how to do a regression, sort of in some respects set me up well for a data science career.
Oh, very nice. I mean, I think a lot of people don't realize these days with all the machine learning algorithms, right, that regression is kind of the sort of foundation for all of that, isn't it?
Absolutely, yes.
Yeah. Okay. And were you using R to do that?
So sadly, I wasn't. We were using a piece of software called Stata.
Stata, okay.
Stata,
yeah.
Which I reflect back on and do sort of look back on it in dismay, because I guess in some respects they wanted to keep us in academia, because Stata is quite widely used in academia and especially for econometrics. But it doesn't prepare you well for the working world, and most companies don't really use Stata.
Mm-hmm.
Yeah.
Yeah, that's interesting. But it was easy enough, like you had enough of a background to move over to, because I understand that you use both R and Python?
I use R mostly, but I use Python very slightly, yes, to do a few things here and there.
Yeah. And what would you say that are some of the things that you use R for versus, say, Python for?
Yeah. So the power of R comes in when you want to do more statistical things like multi-level modeling and Bayesian techniques to analyze your data and to draw inferences from it. Because that comes from the root of R being a statistical language that was brought about by that sort of community.
Yes.
And because of that, it's got more support and more packages available that allow you to do that. But nowadays I find then that Python also has the capabilities to do that as well.
Yes. Okay. And what were some of the things, the bits and pieces that you use Python for then?
Yeah, so Python I probably use if I wanted to build a more general pipeline, if I want to do more general things. So not just like putting data in, but building a pipeline to get the data running through the system and then having some sort of output at the end, like an app or something like that.
Yeah.
I should note that my Python skills aren't the best.
Yeah, sure.
Yes, so I haven't used it very much. But I do enjoy the fluidity of things like Jupyter Notebooks over something like Markdown, because it's much more quicker to get something visual and get a piece of analysis, say, onto a document with some written commentary.
Okay, that's interesting actually. Like, because you would use R Markdown as well?
Absolutely, yes.
Yeah. And how would you compare, say, Jupyter Notebooks with R Markdown?
So I'd say Jupyter Notebook is much more friendly to the user. It's a
Okay.
bit more intuitive in the way that you have these shortcuts and you have chunks where you could easily write text,
Yes.
commentary, and then you could easily write code and get outputs from that code, like a plot, and then you write commentary again, and so on and so forth. In terms of that, the whole process, it feels much more smoother from the person using it. Whereas for Markdown, it's a bit more, I guess, clunky because you have to write it all in one script, and it's only through knitting the document that's where you get the commentary being neatly aligned with the outputs of the code.
Yeah, it's not as nicely formatted.
It's not as nice.
In line.
Exactly.
Right?
But
Yeah.
at the same time, I feel that because it's a bit more clunky, it also requires you to think more and to be more specific at how you write your commentary alongside your analysis. So if you are to do something like a research paper,
Yes.
you want to apply more thinking, you want to apply more thought to the whole process overall. And in that respect, I would prefer Markdown over Jupyter Notebooks.
Right. Okay. That's interesting. That I guess the other benefit of our Markdown, which I'm not too sure if you use or not, is the fact that you can also publish it to a lot more
Absolutely.
different outputs. Right?
Yes, exactly. So you could publish it as a Word document, as a PDF output, or my favorite, the HTML output.
Yeah.
HTML because it's interactive, and if you're working with business stakeholders at the end of the day, they like having that bit of interaction
Yeah.
to be able to feel that they have some sort of discretion or control over what's happening in the document. Whereas for Word, that you can edit that, you can set that over to people who are not so technically minded, and
Yes.
if they feel they want to make changes to it, it's much more easier for them to make changes on a Word document than, say, a HTML document.
Yeah. Yeah. No. Absolutely. I guess the other formats as well. You've got PowerPoint in there
Yes,
for like
absolutely,
users, and when you say HTML, so which HTML formats do you use in particular? Because I think there's actually a whole ton of them as well.
Yeah.
Like Logdown and like Flex dashboards is some of the stuff I teach.
Yeah. So I use the standard Markdown sort of HTML output that's generated when you knit. What's been sort of captured in my interest quite recently is a package called Tuft, Tufte.
TUFTE.
Yeah,
Okay.
which is quite beautiful in the sense that the problem that I've had with sort of these HTML documents and Markdown is that when you do your analysis, you have your code, you have your plots and your outputs, and they come underneath each other.
Right.
But you have a lot of space on the side, and I feel that that's a lot of wasted space.
Yeah.
So using this sort of package called Tuft, I think it's named after Edward Tuft who created it.
Okay.
It allows you to place those images on the side, so you have a much more compact document overall, and it looks quite nice because, well, it looks kind of like an academic research paper. Where you have
Nice. So
the
it gives you
plots on
some
the side.
layout control.
Absolutely, yes.
Yeah.
Yeah,
Okay, that's interesting. I'll definitely have to.
it's beautiful.
We'll definitely have to check that out. Okay, and I understand that you're a big fan of Shiny as well.
Absolutely, yes.
Yeah.
Yes, Shiny is fantastic if you want to bring your sort of what you do in art to life and to make it much more widely used for other people, because you can have, well, I guess, well, I should share my good news. So today, earlier this afternoon, I found out that I'll be giving a talk at an ELF conference, and the subject of this talk is for my experience that I was working on when I was helping to organize a conference last year.
Yeah.
And the problem that I had to deal with in particular was you have a set of people coming to the conference, and you have talks at the conference. These people have preferences over what talks they go to because these talks are happening at the same time. So how do you match this set of people to this set of talks, given that these people have preferences? And so what started off as using a algorithm that was already sort of off the shelf, should I say, it already exists as a package, led to me creating a more bespoke and simpler algorithm. And yes, I was able to use that algorithm for the actual matchings that we were making between the people in the talks for the conference. But look at it from a more longer term perspective, I won't be doing this. I won't be volunteering to help out the conference next year. So the idea is, whoever is taking my position next year, how can I make sure that they continue using this sort of product that I created, this algorithm that I wrote, with respect to whether they know how to code it or not. And so that's where you bring R Shiny into play, because you can put R Shiny on top of that, on top of the algorithm, so that you're making the algorithm accessible to both technical and non-technical users. Because when you have an R Shiny on top, you have an app that the person uses, they access the app, they input the data into the app, and they press a button to get the algorithm running on the data that they put into the app, and they get the outputs from that.
Very
So
nice.
I think the power of Shiny is making R, what you do in R, accessible to a wider audience.
Absolutely. And I think the fact as well is because obviously you could build applications in all types of different programming languages. One of the things I find interesting is that a lot of the arguments for something like Python is the fact that you can build web applications with things like Flask. And I find that really quite funny in a way because, well, not that it's not true and you get a lot of control over those applications, but you can build a Shiny app in like a tenth the time. So
Absolutely, yes.
it's just so fast for building that kind of thing.
Exactly, yes. And it's also the fact that it sort of makes the process of building apps much more accessible, because
Yes.
you don't have to necessarily know how to build an app. You don't need to know Java or JavaScript or CSS or HTML to build one in the first place, because all you need is to know how to code in R, and then the R code writes the HTML to CSS code for you.
Yeah, no, absolutely. And it's really so much more compact as well, isn't it? Because when you do something like a visualization, you know, really like it's the amount of code that is used to make your R plot, right? So which may be like a line of code or something like that.
Yeah.
If you were to move to something more complicated, like if you were going into JavaScript, and especially if you're going into something like D3,
Yeah.
that could be like 50 lines of code.
It can be daunting, but it does make it much more easy to use because you're using something like Shiny, yes.
You mentioned that you have some math background as well. How much math would you say that you need in order to do data science?
In order to do data science, I guess it depends on how much you want to understand what happened underneath the hood of, say, a random forest or aggression, for instance. I find that most of the time you could get by with having a practical understanding of how things work.
Yes.
And if you have a practical understanding of how things work, then I suppose the equivalent of an A level just before you go to university, that level of mathematics is sufficient for you to get through. Much more important is statistics, I would say. It's be aware of statistical concepts, which are quite frequent within the data science field. I think that's probably much more important, and I guess a basic course in statistics at university would be the right level to pitch yourselves at
Yeah.
for most roles in data science.
Okay. So yeah, that's interesting. So I mean, I think that you don't necessarily need to understand what's going on underneath the hood of different algorithms, right? Would you say that maybe the math is a little bit handy for certain things, like certain feature engineering and different things like that?
Absolutely. Yeah, I'd say that'll probably be quite useful actually. Yeah, you are completely correct. Yes.
Yeah.
Yeah.
Okay. And what would you say are some of the maybe key statistical concepts that are useful?
So from what I've used and from what I've experienced so far, it's sort of knowing stuff like hypothesis testing, knowing things like significance testing, and various things like p-values, and be able to test for statistical significance. Those are quite important, as well as things like distributions, understanding what distributions are, how to use them. Those sort of fundamental things are a good starting point.
Yeah, no, absolutely. And do you work with clients directly much, or do you work more within a back office team? Or
Yeah. So I've recently moved teams within the Department for Education, and in my old team, I was more in the back office side of things. But in my new team, I'm much more close to the clients themselves, so you use the outputs that we have.
Yeah, and that's where Shiny comes in handy. And
Absolutely, yes. That's where it comes in handy, because you want to be able to communicate in the smoothest and quickest way as possible with them, so that they understand as well.
yeah.
Yeah.
And how do you find communicating, kind of statistical and kind of data science concepts with clients?
It is quite a difficult. It's difficult to do, and I'd say from my personal experience, the best way to describe these things is you don't need to tell them everything. You don't need to tell them the inner workings. It's
Yes.
like the age of saying, people care about the sausage, but they don't care how the sausage is made.
Yeah.
Yeah, so
Yeah.
you give them outputs and you tell them how you got to the outputs.
Yes.
And you like have a sort of, you create a narrative, a story thread. So say when we're working with one client, we say, this is how our model works for you. There's these inputs, this affects your level of risk, and this is how you can sort of adjust your practices so that you're not as likely to be of risk in the future. So personalizing the communications to them and giving them a singular example rather than talk about the general high level, no, rather than talk about the general way in which, let's say, algorithm works. I
Yeah.
think that's probably most useful to them.
Yeah, no, absolutely. Breaking it down into the language they understand
Yeah.
and focused on their problem, right?
Absolutely, focus on the problem and the outputs, or how they can use the outputs for their purposes.
Okay. And you mentioned earlier that you have a few opinions about a few things.
Yeah.
And, could you tell us a little bit more about that?
Yes. So nowadays I feel, because R's fantastic, it can do many things, but as I touched on earlier, most companies nowadays are using Python, and I feel because Python is much more general and it can link much more better with other pieces of software, other languages.
Yes.
I find myself pivoting more towards Python as a consequence of that, because I'm gonna make myself as sort of flexible as possible
Yes.
to ensure that I can adapt to the different needs of the market as and when
Yes.
they come.
Mm.
So that's one of the sort of strong opinions I have. That's not to say that R is obsolete. R is still fantastic.
Yes.
But if you want to make yourself as widely available as possible, be knowledgeable of both R and Python would be very useful.
Mm.
Yeah.
Yeah, no, I think so. I mean, definitely. I think that generally people who have the skills to do one can probably do both. But I don't know if your opinion on this, but it's probably difficult to learn two at the same time.
Absolutely, yes.
And would it be a fair comment to say that R is probably still an easier language to pick up, especially if you're from a statistics background?
Yes, absolutely so. Because I feel that the range of things within R is smaller than in Python, say. So as you say, R is much more easier to learn from if you have a statistical background. If you have a sort of computer science background, Python is a bit more easier to learn because of the various ways you think about, the various ways you approach things from the different educational backgrounds that you have. And on top of that, trying to remember what I was going to say.
Okay. So one thing I thought was interesting, actually,
Yeah.
because I studied a bit of computer science and stuff myself, and so Python, I find, is it's inherently an object-oriented programming language.
Yeah.
So it's a really, really useful concept to learn. So R also implements object orientation, but it's, to be honest, a little bit strange.
Yeah.
But what R does really well, which I find a lot of the new programming languages are actually headed towards now, is a more functional programming language style. Right? So I think that's something that R does really, really nicely. And for those who aren't familiar, functional programming is generally better for kind of mathematics and statistics and different things like that. And I think as well that besides just, even if you're not necessarily in a statistics background, if you work with if you come from a background where you're working with things like Excel or databases, I think R is still a much easier transition to work with than, say, something like Python. And plus the fact you've got things like Shiny and everything. I mean, these days you've got things like Tidyverse and different things like that. And which just make it so much easier to pick it up and learn the language.
Yeah. I guess, if you touch upon Tidyverse, then it's knowing that entry point into R, because when you have a problem in R, you usually search on Google, you have Stack Overflow.
Yes.
And the problem is that many people have various ways to approach things.
Yes.
And you can use base R. Sometimes base R is a fast implementation.
Yes.
But you can use Tidyverse, and that's much more transparent and easy to understand. Different people have their own preferences, and I think what sort of things they're trying to do in the last several months, maybe years, is trying to direct people towards a best approach to using R, and that is within the Tidyverse itself. So that's something we've done within the Department for Education. we've been trying to encourage people as a starting point to use tidyverse, because once you enter R via tidyverse, it's much more easier for you to pick up
Yeah.
how R works and how to code in R generally.
Yeah, I mean, it's a single set of standards.
Exactly, yes.
Yeah.
Yeah.
And on top of that, it's got some really, really nice functions as well for doing all kinds of things. It's very efficient.
So it's quite comprehensive, I'd say, yeah.
So what do you love most about working as a data scientist?
It's just how big the data science world is, incredibly so. There's just so much to it. You have machine learning, you have deep learning, you have neural networks, and more recently quantum computers, and how that can change things so completely. So having this rich and massive world, it can be quite intimidating, but it's finding where you fit in amongst all these different arrangements in this world. Do you focus more on, let's say, software development? Do you focus more on the architectural side? Do you focus more on sort of machine learning, running algorithms, that sort of stuff? It's sort of bracing to know that you will never be the best, but you can do whatever you can to get to the top and to learn as much as possible. It's it's quite humbling, and from someone who's really curious and who really likes to learn.
Yes.
Data science is a fantastic space because the research is active. There's always new things happening. Like, for instance, there's been really rapid developments in generative adversarial networks, and in particular, the ability for algorithms to produce like fake faces off a set of like real faces you feed into it. And the thing was that they could do that before, but the background that you have the faces against were always a bit, they always gave the game away, and that's because when you feed the data into it, the faces are more or less quite similar, the structure, the ratios of eyes, nose and mouth to the face, to the ears, but the backgrounds in these images can be so varied and so different, but that GANs, or GANs is what they call it for short, they're able to overcome this, and now you have a website, this is not a real person, where every time you click on it you get a new face, and they're very convincing. So
it's pretty impressive.
It's phenomenal, and
it's
knowing
incredible.
that there's always these new developments happening as they go along, and they can be quite trivial to say recognize a cat, and they can be quite powerful in terms of helping to improve the diagnostics of cancer and treatment of cancer.
Yeah.
So knowing that you can do really good, powerful things, as well as solve trivial things as well, is
it's an absolutely incredible field, right?
Absolutely.
I think there's just so much out there.
Yeah.
And as you mentioned before, it can be like quite intimidating, but at the same time, I think that it's important to realize that you don't necessarily need to learn everything.
Yes.
In fact, it's impossible to.
Yes.
Yeah.
So it's about knowing what you finding your, I guess, niche within that area, and sort of following through and be as open as possible to what's happening in the sort of big wide world of data science.
Yeah, so I mean, I think probably a good approach to start with is starting quite wide in general, just so that you understand what all the different tools available are to solve different types of problems.
Exactly.
Find a role or problem that you want to solve and you're passionate about, and then find the best solutions for those problems.
Yes, absolutely. And building up that experience, building up the uses of these different techniques, so you become much more familiar with them as well.
Yeah.
Yeah.
Yeah. And I think, as you mentioned, this is one of the first things you mentioned, I think, is just the ability to learn is probably one of the most important things above all else, right?
Yes. And it's not just the ability to learn, but the sort of having to be proactive in searching for that learn and use a variety of sources. Yes, you could go on training courses, you could pay £400, but you can also go online, you can look at other people's examples, and that's all free, and that's also another skill in itself, finding different resources and sort of bringing them together to help tackle the problem that you have.
Yes. I mean, it's really problem solving, right?
Absolutely, yes.
And I think that, there's the more work that you can leverage, the better.
Yeah.
And I think, these days there's so many open source projects, but there's a skill in itself being able to find the right one.
Absolutely, yeah.
Right? And then being able to pick that apart and use it and apply it and adapt it to whatever you're trying to do.
and it's a skill of so taking it on, trying to apply it to your problem. So sometimes it fails, but knowing that, oh, how can you improve it? How can you continue to look for other sort of techniques that you can use to help solve your problem? Just be open to those set of techniques that are available to you, and constantly testing, constantly adapting, constantly iteratively improving. That's quite key, I'd say. Yeah.
Yeah, no, absolutely. Because I think, people don't, well, I don't know, maybe they do realize or don't realize, but data science, everything in the field is changing really fast.
Yeah. Yeah. And it takes a lot of perseverance to sort of be able to withstand and accept that what you know now, give it 3 months, it's pretty good. There's probably going to be something that supersedes what you know, and you just need to learn again and again and again.
Yeah, no, it's interesting that, because I mean, especially some of the kind of newer libraries, which haven't been around for so long. Like, I'm not too sure you saw the news on TensorFlow, that, TensorFlow is now replaced by TensorFlow 2. And so anything that you learned about TensorFlow before is pretty much out of date.
Yes, exactly, yes. But knowing that, yes, it's out of date, but with the hope and expectation that whatever replaces it is much better, and you want to use what's better. You want to constantly strive for that.
Yeah, and that's the thing. A lot of times the stuff is, becoming better. And so you kind of want to almost, you want to know generally what's available so that you can use it for the problem that you're going to solve.
Exactly.
But a lot of the version 1 versions of the libraries and all these kind of things are probably very, very difficult to work with.
Yeah.
And so if you're learning it before you need to use it, that's probably a bad idea.
Yeah. Which is why I'm keen that when you sort of learn sort of programming, when you learn R, for instance, you learn it alongside the project that you want to do.
Yes.
To apply immediately what you learn alongside your project. So you're consolidating what you're learning into something practical, and you have something to show for it at the end. So that, say, your manager asks you, so what have you done? You're not just saying, I read these pages from this book. You're saying, I've got this document that shows exactly that I've analyzed this data. That's useful for us because it's our data.
Yes.
It generates these outputs, and you can draw these insights from it. So you're not just benefiting yourself, but you'll be your benefit to the business. You can use what you're learning immediately.
Yeah, no, I think what you just said is probably one of the most important things, really, that, you really have to apply what you learn.
Exactly.
Like, if you don't apply what you learn, then, well, you're not really going to be able to remember it anyway.
Absolutely, yes. Yeah. Which is why I also have strong opinions about sort of training and what you do to pick up the language in the first place. I'm always of the persuasion that if you're trying to learn R,
Yes.
you don't go on a £500 training course and sit in a classroom and just learn it. You have a project. You interrogate Google all the time, Stack Overflow, whatever sources are out there, and you know exactly what you want to do. Interrogate Google, work with the data sets, sort of code it R, and make sure that you're actively seeking out solutions to your problem, or just sitting there digesting what's in the book and maybe looking at answers to the questions as well. So.
Yeah, no, absolutely. I think starting with a problem, I think that to start with, depending on where you're at, right, I think it's useful to, learn some sort of fundamentals and foundations so you can get up and running. And probably the one problem, I mean, obviously Stack Overflow is an amazing resource, and so is Google.
Yeah.
One of the things that I found, though, is one of the things you mentioned earlier before, though, is just the fact that, when you go to something like Stack Overflow, you don't have the standards in there.
Yeah.
And you don't have, like there's, maybe 3 different methods to do the same thing. And in a way, that can be a good thing, because then you can see different approaches to solving the problem. But at the same time, I think it could be a little bit confusing, whereas you mentioned before that now your team is basically moved to Tidyverse, because then it does enforce those standards.
Yes, indeed. Yeah.
Yeah.
It is a difficult balance to act, actually, because when you do want to learn stuff, when you're learning something new, you don't want to overwhelm yourself with too much information. So yes, you want to know how to code in R, but you can't necessarily handle the extra information. Or you did it base R, doing Tidyverse again. So that can sort of stop the flow of your learning. So I guess the balance here is you allow people to you teach them as they go along. So yes, you learn how to do how to produce a GG plot. No, you know how to produce a base R plot. Fantastic. And you say, let's improve that. Let's use tidyverse on top of that. So you need to have those small wins, and you need to gradually build up their skills so that they're confident in using language first and foremost, and then they're confident in using language in the best way they can. I feel that's probably the balance that would be most conducive to learning.
Yeah, no, there's a lot. There's always a lot to learn, isn't there?
Yeah,
So,
yeah.
okay. And what's some other advice that you would want to give to people?
Yeah.
Wanting to get started in data science.
Yeah. So definitely have. So would you? I guess I would like to make the question more specific. So when you say get started with data science, do you mean get started with learning how to do data science, or get started in the data science industry?
Good question. How about, can we do both?
Yes. Okay. So to get started in data science, it's be able to, as you say, pick a language, because you don't want to learn how to do C++, C Sharp, F Sharp, Python, R all at once. That's just overwhelming. That's information overload. So pick a language, and I'd say pick it either Python or R, because those are most general purpose, and those are most easy to understand languages when you're a newcomer. Pick one of those languages, build those foundations, and then have practical examples that you apply your knowledge on as you go along, so you feel comfortable in not just programming, but using various data science techniques.
Yes.
So that you can talk about it, and you know the various strengths and weaknesses of each one. And as you do this, what I would recommend to get into the industry is to set up a GitHub account, record all the projects that you're making onto a GitHub account, because the beauty of GitHub account is it's open source, which means you're sharing your knowledge, but you're also sharing the fact that you know how to do this with potential employers in the future. So it's one thing to say you know how to do a random forest, or you know how to run a support vector machine on a CV, but it's completely different, and it's a complete game changer if you can show you can do it on your GitHub, because that reassures the person who's employing you that you're not just saying it, but you know how to do it.
Yeah. Okay. And do you blog and different things like that as well, or?
I do have a GitHub. I do try whenever I do a project, I do try to make it as open source as possible. The biggest example is when I did some Bayesian regressions on sensitive data within the department, but because I wanted to share the fact that I knew how to do this, and I wanted to share the knowledge, then I took an open data set that anybody could download, and I applied the same process onto that data set, put on my GitHub, and shared it with everybody else.
Yeah, no, that's a great thing, actually. It's great because you're sharing the techniques with like all these other people, so other people can pick up and learn from your knowledge and experience.
Yeah.
And you're kind of demonstrating, that you have those skills as well.
Yes. And it's also with the knowledge that none of my work is original. I take all this work from other people. So it's only fair that if I take this work from other people, be it what's on Stack Overflow, be it from this textbook that's published online, or from another person's GitHub project, if I take it, then I should give back as well, because that's sort of the open data sort of mantra is nothing's original, but what you can do is share how you pull together these different sources of people, so that you're learning from these set of people, but you also share what you learned with that set of people as well.
Yeah, no, I think it's interesting that, because these days it's like you said, nothing is original anymore. Like, it's all about taking bits and gluing it together.
Precisely, yes.
Yeah, so you're taking lots and lots of different things, and like all the algorithms these days, they're already written, right?
Yeah.
You're not gonna, most people are not going to implement an algorithms themselves or something like that. They're going to take kind of one of these off-the-shelf models or something like that, and use it to train based on your data.
Yeah. So and it's okay. It's okay to do that, because you don't want to waste time like reinventing the wheel. You don't want to rewrite an algorithm that already exists for your problem, because the algorithm already exists. the amount of people who worked on that algorithm in the first place, who worked on that package, the amount of testing it's gone, the amount of peer review that other people have looked at it,
Yes.
you're not going to be able to get to that same level
Yeah.
in the timescales that you have in the business.
Yeah.
So it's okay to take from other people, and it's even better if you can share it with people too.
Yeah, no, I mean, I think that, if you think about it, all kind of progression that humanity basically makes is because we build on the foundations of
Exactly,
other
yeah.
people.
Yeah.
The fact that I don't have to go out and like make my own pen.
Yeah.
I just buy it and then I can use it and to work with, right? And I think
Yeah.
it's very much that concept that you don't have to prove that you're the smartest person because you went off and did all this kind of thing. That's actually not very smart at all, right?
Exactly,
Because
yes.
you really want to leverage as many things as possible.
Yes.
And so one of the key things really is, like you said, being open so that you can see what's available, so you can see different types of solutions. And become about for you, but I find that for myself, like even if I know how to solve a problem, I'll probably go off and look up 10 different other
Yeah.
answers anyway.
Yeah, because you desire that. You know how to solve the problem, but you're also curious to know, is there another way to solve it? Is there a better way to solve it?
Yes.
If there's not a better way to solve it, why is the way you're using currently better than the previous other ways?
Yes.
Yes.
And that's the way that you make your own work better.
Exactly. Yes.
Yeah. And it's interesting because over time you just become, you develop your own kind of unique expertise and experience because you're not, sort of one person's piece of work. You're the consolidation of maybe 10 people's
Yeah.
types of pieces of work, right?
Absolutely. Yeah. So the key skill is not be a not be a original thinker or be a counterfeit. I guess that's what we could teach your kids at home.
Yeah. I mean, I think it was Steve Jobs who said something along the lines of, it was Steve Jobs that, we unashamedly basic copy
Yeah.
stuff,
Yeah.
something to that effect,
Yeah.
right? And who was it? Like I think it was Picasso or something who made the statement, good artists copy, great artists steal. Right? And I mean, that's not to say that you should go off and copyright other people's
Absolutely
work
not,
and stuff
no.
like that.
Yeah.
But really, the fact that we learn anything is based on other people's knowledge,
Yeah.
and building up as much of that as possible so that we can do our own work and then make our own unique interpretations of that. I think is really a skill in itself.
Absolutely. Which brings us back to the question of the key skills that a data scientist
Yeah.
would have, and that's pulling together these different pieces, and not necessarily stealing it, but being open to different ideas and bringing it together
Yeah.
to solve your specific business problem. Yeah. So I think that's one of the core skills.
So you were mentioned that you went to a data science festival,
Yeah.
and you saw quite interesting talk.
Yeah, so at the Data Science Festival, there was one of the talks at the end was this guy with a very interesting startup, and the unique selling point for his startup is what they did is they were able to take data from the blockchain and process it through both a relational database and a graph database as well. A relational database, so you could conduct traditional analysis on how many trades were made, where these trades were made, what points in time of the day they were made, and a graph database to illustrate to his clients how this person who made this transaction on the blockchain is related to that person who made that transaction on the blockchain, and to illustrate how the different trades and the movement of the trades take place over time, because like any market, the blockchain market has people who are called whales who hold a lot of, let's say, Bitcoin, and when they move their funds across the market, that they can really affect the prices. So using a graph network, he was able to explicitly demonstrate who these people were, and sort of illustrate from the size of their nodes
Yes.
how influential they are compared to other people, and sort of group those people together as one cluster compared to
Okay.
other clusters. So that was quite insightful, and it's also interesting to see how technically demanding something like taking data from the blockchain is, and then getting insightful outputs from it. So that was one of my favorite talks for the Data Science Festival.
Yeah. Okay. No, that's interesting. Yeah, I think sometimes there's like all these different technologies, and people are trying to decide between this and that. And these days, I think that it's almost more of an architecture kind of question, right? Because it's like, when do you use what? Right?
Yes.
Don't just use the latest thing because it's the latest buzzword or whatever it is, but use it because that kind of solves the problem really well.
Yeah, and not just your current problem, but future problems that you may have ahead of time.
Yeah. No, absolutely. And I think as well that these days, like you mentioned, graph network analysis which is something I'm quite fond of as well. It's, there's so many different kind of models that you can use to put your data in. And, you can actually take the same data and put it in lots of different types of models, depending very specifically on what your objective is.
Yeah.
Right. So, if you're analyzing more traditional data, maybe a relational database, I would probably pick a column store database instead, because that's going to be much faster processing. So something like Spark or something like that. But like a graph database is very good for looking at the connections between different nodes, the centrality of them, and so gauging importance, different things like that.
Yeah, I think because there's also, as you know, there's the data science space and community is quite big in London. One of the vendors of a graph database, Neo4j, they hold a few meetups themselves where they sort of talk about how they analyze data using a graph database. And it's exactly as you said, it's fantastic for showing the relationships and the movements of these relationships. One of the examples was in sort of the football world and transfers particularly, how players move from different teams, how they relate to each other, that sort of stuff. And it's really powerful because you can see explicitly how it works and how things are linked.
No, Neo4j is great. I think that they've done some amazing work at taking graph networks, which have actually been around for a very long time. And so it's not like they're the only graph database provider around. But one of the things that they've done really brilliantly, I think, better than a lot of the other providers, is made it a lot more accessible and made it much more applicable to actually people's problems. Because up until Neo4j came along, I just found that a lot of the graph network stuff has been very, very academic and very, very theoretical. So.
Yeah, that's I guess the key to trying to get traction. That's similar to, I guess it touches upon the theme of scalability, and in particular, so the research that's made in the quantum computer space, IBM, Microsoft, a few other startups. What will clearly define them is whether they can make it scalable and applied for businesses themselves. So that will sort of decide who sort of has control or influence.
Yeah, that's interesting. So let's talk about scalability actually, because this is a really interesting topic. It's a word that comes up a lot. And in your mind, what do you mean and what do you think of when you think of scalability?
I guess when I think of scalability, it's not just be able to handle larger volumes, but be able to dynamically deal with different types and different structures. So that when you're talking about scalability, you're sort of looking at it from a longer point of view, in the sense that it can solve your problem now, but it's also adaptable for problems in the future too.
Yeah, no, I think that's a good one, because even if you don't necessarily have any users, you don't want to give to anybody, you still want to be able to adapt your solution. So, instead of just running one model and prepping everything to work with only one model, maybe you want to set it up in a way that maybe you can run like 1,000 different permutations of that, right? And you want the flexibility to do that.
Precisely, yes. Absolutely, yeah.
And then, when it comes to other things like users and all this kind of thing, it's like, well, thinking about, okay, does your model have like a particular end user? And, then you've got things like Shiny and stuff like that, which is a nice way of I mean, if you compare it to something like an Excel spreadsheet,
Yeah.
like spreadsheets, one of the main drawbacks and problems of them I find is that you've got a scalability of like 1,
Yeah.
right? You basically have zero scalability when it comes to Excel because they're not very reusable without
Yeah.
manually adapting them.
Yeah.
But when you get into something like code and you have a way to take your work and deploy it as, say, a web application, which can reach, say, thousands of people,
Yeah.
then you do have something which is a scalable solution.
Yeah. And it can meet different users' requirements and stuff like that. Problem with Excel actually is you have to know how it works and you have to know how to navigate it. And it also depends on how that person designed it in the first place.
Yeah.
So good design practice nowadays is to be agnostic in terms of who uses it and how they use it. So it should be as intuitive as possible to use it. And so personal experiences are that Excel spreadsheets are generally quite difficult in that respect.
Do you have quite a big team?
So my old team was quite... So my old team, if you were to talk about it from a sort of the data science division itself, there are about 150 people.
Yeah.
Most of whom were on the data architecture side of things, so manage our data warehouse, manage our data collections, and so write out the documents to collect data from different organizations and stuff like that. But in terms of people who sort of build models and run algorithms and stuff like that, you reduced almost 150 to about maybe 10 to 8 people. So that's why it's quite difficult to say what do you mean by data science, because it can capture many people really. And data science is a catch-all term because you do need data engineering skills, you do need architectural skills, you do need analytical skills, you do need visualization skills within that space. So, yeah.
That's interesting. I mean, would you say that all of these people should be called a data scientist, or do you think there's lots of roles that should all be labeled data scientists, or do you think we should have like more distinct labeling in the field? Or
Good question. I feel that a data scientist sort of classically is someone who is sort of like a Da Vinci. They could do a bit of everything. They could do a bit of architecture, they could do engineering, they could do a bit of analysis, they could do a bit of visualization, and a little bit of business context too. But when you get people who exclusively do one thing, I think that will sort of veer away from that idea of data science. So when you have people who just specialize in data architecture, then it's probably more accurate to describe them as data architects rather than data scientists, because they have a very specific skill set within data science. But to call them data science would sort of invite a misunderstanding that they would be able to do sort of data storytelling, or they'll be able to sort of use data science techniques at random forest. So
it's interesting because I think that because a lot of people don't really understand data science that well right now, right? So I think that the labels are a bit of a tricky thing because maybe you're a data architect, but nobody knows what a data architect is, even though they need one.
Yeah. Yes. Yeah.
So I think I mean, obviously, if there was a role for a data architect, maybe you'd write your title as data architect.
Yeah.
But if you looked at a role, most of the roles are probably going to say maybe data science, data analyst, or something like that.
Yeah.
But I think you really got to look a little bit deeper and look at what are they actually looking for.
Yeah. That's why usually if you're in the field, you look at the job description, look at what sort of you're expected to do, and then you sort of form your judgment based on job description rather than the job title. There's no recruiters on LinkedIn, and a lot of them are looking for data scientists. But as you say, both the recruiter and probably the company themselves don't necessarily know what sort of, data scientists they want.
Yeah, it's interesting because I noticed that like these days there's like a lot of data science roles, and they have like this really big list of all these things that you're supposed to know.
Yeah.
And sometimes I look at those lists and I think to myself, it's like, I bet they're not using some of those things, right?
Yeah.
Some of those things on the list sometimes are like already out of date.
Yes.
Right?
Yeah.
So for instance, you're supposed to know Hadoop. It's like, nobody uses Hadoop anymore.
Yeah, yeah.
Which makes me wonder sometimes about the roles that are actually being advertised. And if the people who are like putting together these roles really understand what they actually need or are
Yeah.
looking for.
I think that was actually that's a good point. That was actually sort of covered somewhat in 2 years ago.
Yeah.
And you go into these job descriptions, and the idea is that, say you are interested in the role, but you're put off by the fact that maybe they want you to be able to use Spark or Hadoop. Well, that's just one thing that they want from you out of, let's say, 10 things. And it's more of an attitude thing, in the sense that some people feel like they have to be 100% confident for them to apply for a job.
Yeah.
Others only need to be 60% confident for them to apply for the job. And if you take that knowledge that companies don't really know what they want themselves,
Yeah.
then if you are 100% person, if you are that 100% person who says, I need to be confident 100% I can do this,
Yeah.
well, that means even if you don't meet everything on that criteria, you should still apply for it, because chances are that company doesn't actually need all those things that they're specifying and laying out, and therefore you should just apply for whatever you see or that you meet most of the requirements for.
Yeah. No, I mean, I think if you have a general understanding
Yeah.
of if you've done some work already, right?
Yeah.
If you've done some sort of data science project,
Yeah.
if you worked with R or Python and you
Yeah.
know what a data frame is,
Yeah.
then you're going to be able to transition those skills over to something like Spark.
Exactly,
Anyway,
yeah.
right?
Yeah.
It's going to be more work. It's going to be like a little bit more work. But if they actually have a Spark server in place that you can actually use and play with, and if you're using something every day,
Yeah.
you're just going to pick it up and learn it, right?
Yeah.
And so I think that a lot of times, and this is a bit of a tricky thing in a way, right? Because we were talking earlier, it's like, okay, well, Python's really kind of popular now and everything like that. But actually, if you know R or Python, you pretty much pick up the other one,
Yeah.
like if you have a job that uses it. Because once you start using it every day,
Yeah.
you'll just pick it up and you'll use it. Right?
Absolutely,
And I know a lot of people who will use both. As soon as they stop using it, right?
Yeah.
And they might have been using Python for the last 3 years, and now they're on an R team who uses all R. They'll forget how to use Python.
Yeah.
Right, and vice versa.
Yeah.
Right? Obviously, you'll remember like some of the basics and all that kind of stuff like that, and you pick it up again. But like if you have some core fundamentals, I think you'll kind of pick up whatever.
Exactly. Yes. Yes.
Because I mean, like you mentioned before, you started with Stata,
Yeah.
and then you moved to R.
Yeah.
And did you find that was much of a, did you find that was difficult to make that switch at all? Or?
I'd say it wasn't difficult at all, partly because I didn't understand Stata in the first place.
Okay.
So I was essentially starting from a blank slate.
Yeah. Okay.
But I did do courses in JavaScript, and I did a module in Java as well.
Yeah.
So the concepts of loops and if-else statements, those
Right.
sort of things, they're sort of fundamental, and they're quite consistent across different languages.
Yes.
So already be familiar with those sort of concepts means your integration into this language, say R, is much more easier because you're familiar with the concepts, and it's just a case of knowing the language itself.
Yeah.
So think of it like
absolutely.
you know the sort of grammatical structure, you just don't know the actual words to put inside that grammatical structure.
Yeah.
That's how I think of it.
Yeah, no, absolutely. Basically, find your project, find out what you need to do, break it down into like small chunks,
Yeah.
find yourself a cheat sheet, and
Yes.
maybe a buddy or something like that.
Yes.
That,
Yes.
that can help you out, and away you go. So
That's right, yeah.
I really appreciate your time here today. Any final thoughts or that you'd want to share with anybody?
Any final thoughts? Oh, that's a difficult question, actually. Well, thank you for interviewing me, Jonathan. It's been a pleasure to discuss R and to discuss data science more widely,
Yeah.
in particular, and to really think about what makes data science and what makes the data scientist a good one, and discuss the key skills. And I guess these are all based on my own personal experiences. I'm more than happy for people to disagree or to reject what I say. It's perfectly fine to disagree and to have, I guess, constructive criticism and discussions on this thing. And the whole point is just be open and be sharing the work in whatever possible way you can. Yeah.
So I hope you really enjoyed this conversation with Avision. I think it's really interesting and inspirational how people from very different backgrounds get involved in data analytics and data science. Increasingly, my friends are a mix of both R and Python users. I still think there's a really good use case for both languages, and I'm looking to put together a new course that discusses how you can learn and get the best from both worlds. If you're interested in that, or you have any questions or comments that you'd like to ask Avision, myself, or other future guests, please leave a comment below. In the meantime, thanks for tuning in, and I'll see you next time.